Hey guys, so I hope you had a great vacation. Now it's time to go back to reviewing Lewis structures. I know it's been about 2 weeks, so you might have already forgotten a couple of things, but we'll go over it. So the first thing I need you guys to know about drawing Lewis structures is how to find the correct number of valence electrons. We do this by observing which group of the periodic table you are currently in. So if I'm in group 1, I'm going to have 1 valence electron, 2, and then we're going to jump over D block because we're going to ignore these for the purposes of this course. And then we're going to go 3, 4, 5, 6, 7, and 8. Now, of course, there are exceptions to these rules, so it's not a cut and dry thing. You will find some elements that are in different groups that have different numbers of valence electrons, but for the purpose of this class, you're just going to follow this rule, okay? So for example, let's say I wanted to draw the Lewis structure of nitrogen. I know that nitrogen is right here, so he should have 5 valence electrons. How I would do this is I would first draw the chemical symbol of nitrogen, which is just a capital N. And then in a clockwise or counterclockwise, it's up to you. You start filling in the electrons one by one on each side of the element. 1, 2, 3, 4, 5. Now the reason I do this is because if I don't do it in this manner, I might end up making some mistakes. So you see these guys right here? These two are a lone pair. They're happy together. They don't want to be interacting with anybody else, so they are not involved in bonding. You will never see a bond being formed here or here. Now, the ones that are involved in bonding are these 3 that are alone. Right here, and right here, there's a missing electron. So here, nitrogen can form 3 different bonds with elements, right? Because it has 3 empty spaces where other electrons can come and fit in. Let's try another example. Let's say fluorine. Fluorine has 7 electrons, right? So the way I would draw this is like this. Fluorine. 1, 2, 3, 4, 5, 6, and 7. So I know that these two, and these two are all lone pairs, so they're not going to be involved in bonding. But this guy right here has an empty space right next to him, so he can form a bond with another element that is also missing a space in their valence shell. So let's say, for example, hydrogen. Hydrogen has 1 electron because he's in group 1, and he only needs 1 more electron to be happy, right? So what hydrogen can do is it can form a bond with fluorine. So now hydrogen has 2 electrons in its valence shell. He's nice and happy. And fluorine has 8 electrons in its valence shell. So he's also happy and stable. Now we've created a nice, stable compound, right? All by filling in our valence shells. Okay, so we're going to try an example here. Our example is N2, which is just nitrogen gas. The way I would do this, of course, just like you saw earlier, I know that nitrogen has 5 valence electrons. So the first thing that I want to do is I want to draw my Lewis structure of nitrogen, just so I can get a good idea of what it looks like. I know that nitrogen can form a bond here, here, and here. And I need 2 nitrogens because it says N2. So I can put another nitrogen here. Oops. Anyways, you know what it looks like, here and here. So I know that there's a bond that can be formed there and there and there. So let's try to figure this out. You will mess around with this a little bit until you find a method that works for you, but you can just do it like this. I know, logically speaking, that if this nitrogen needs to make a bond, it can make a bond with the one directly across from it. Here, this one also needs to make a bond, so it can make a bond with that one, and this one can make a bond with the last one. So now, this nitrogen has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And this nitrogen also has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So the reason I draw a line is because that's where a bond has formed. So to make our lives simpler, we can just draw it like this. And don't forget your lone pairs on the outside. These lone pairs right here are very, very important, especially later on when we get into molecular geometry. Now, if I want to check to make sure that my answer is correct, I'm going to go through this whole process right here. It sounds a lot more complicated than it really is. So the first thing I'm going to do is I'm going to calculate the total number of electrons in the atoms before they form a bond. I know that each nitrogen carries 5 electrons. So before anything, I can do this. 5 electrons times 2. Now I went times 2 because we have 2 nitrogens. So in total, I have 10 electrons in the atoms before they are bonded. To make sure that I've done this right, I need to make sure that my bonds at the end are also made up of 10 electrons. If I have 11 electrons here or 9 electrons, then I know that there's something wrong with my structure, that there's something missing in it. So right now, I'm going to go ahead and calculate the bonds and the lone pairs. Each bond counts as 2 electrons. As you can see here, 1, 2 make up 1 bond. And then each lone pair also counts as 2 electrons. So the lone pairs, I know I have 2 lone pairs times 2 electrons each, plus the bonds. I know I have 3 bonds times 2 electrons each. So here I have 4, and here I have 6. In total, I have 10 electrons. So this is 10 electrons. This is 10 electrons. That means that this structure is most likely correct. We're going to do another example here. A compound that has 2 chlorines, 2 fluorines, and 1 carbon. So the first thing I want to do is I want to go to my periodic table, and I want to figure out how many valence electrons each one of these structures have. So I can see that carbon here has 4 valence electrons. Chlorine and fluorine are both halogens. They are both in group 17, so they both have 7 valence electrons. So let's go back to the example, and let's go ahead. So let's draw carbon. Carbon looks like this. 1, 2, 3, 4. Fluorine looks like this. 1, 2, 3, 4, 5, 6, and 7. And chlorine looks like this. 1, 2, 3, 4, 5, 6, and 7. So I can see here that carbon has 4 empty spaces. Fluorine has 1 empty space, and chlorine has 1 empty space as well. And I have to remember that I have 2 fluorines in this molecule and 2 chlorines. Now, in a molecule like this, I can expect to have a central atom. To choose the atom that goes in the center of your molecule, you should basically go for the atom that has the most number of empty spaces, or the atom that can form the highest number of bonds, because it just makes sense that all the other ones are going to be sticking to it, right? So I'm going to go ahead and draw carbon right here. 1, 2, 3, 4. And then fluorine can form 1 bond, and I have 2 fluorines. And chlorines can form 1 bond, and I have 2 chlorines. So what I can do is I can draw the chlorines like this. 1, 2, 3, 4, 5, 6, 7. And between them, I can draw a bond. And then I have to draw another chlorine. It doesn't matter where you put the chlorine because we're not really getting into that level of complexity. Chlorine, 1, 2, 3, 4, 5, 6, and 7. Now, fluorine is going to go in pretty much the exact same way. Fluorine, 2, 3, 4, 5, 6, and 7. Another fluorine. So this is what my compound would look like. It would be a carbon in the center and all of these sticking out the side of it. Remember that we have to draw our lone pairs. Just that's part of what you're supposed to do. Now let's check to see if this is correct. Remember, if the number of electrons in my atoms is the same as the number of electrons in my compounds in a neutral compound, then I know that I've done this correctly. The first thing I can do, I can draw carbon, fluorine, and chlorine. Carbon has 4 electrons, fluorine has 7 electrons, but it's times 2 because there's 2 fluorines, and chlorine has 7 electrons, and it's times 2 because there's 2 chlorines, right? So here I have 4, I have 14, and I have another 14. 8, 9, 10, 11, 12. Okay, so I should have 32 electrons in total, right? Then here I'm going to start adding up the number of lone pairs. I know that each one of these has 3 lone pairs, which means I have 12 lone pairs times 2 electrons in each one equals to 24 electrons in total for the lone pairs. And now, how many bonds do I have? 1, 2, 3, 4. So for bonds, I have 4 times 2, because remember, each bond is made up of 2 electrons, which would end up giving me 8 electrons. In total, I have 32 electrons at the end. So if I have 32 electrons here and I have 32 electrons here, that most likely means that this structure is correct. Okay, and this is the last example we're going to go over today. If you get the basic idea, then you can just go right ahead and start doing the worksheet from now. The worksheet is going to look very similar to this, except it has different compounds. All right, so when I have an example like this, I'm going to do it the same way I've done pretty much everything else. I know that carbon has 4 valence electrons. I know that oxygen has 6 valence electrons. Oh, oops, see, I made a mistake there, completely wrong. So, oxygen, 1, 2, 3, 4, 5, 6. Actually, that could have worked out. Anyways, I know this because oxygen is right here, and there is a 6 right there, okay? And the final thing that I need to know is that hydrogen has 1 valence electron, and I have 2 hydrogens in this compound. Now, to figure out which element is in the center of my atom, of my compound, I have to figure out which one of these has the highest number of bonds that it can form. Hydrogen can only form 1 bond, because remember, hydrogen only needs 2 electrons to fill a full valence. So this can't possibly be it. Oxygen only has 2 empty spaces, so it can form 2 bonds, while carbon has 4 empty spaces, which means that it can form 4 bonds. So logically speaking, carbon, because it can form the highest number of bonds, it should be in the center of the compound. So I'm going to go ahead and draw carbon like this. 1, 2, 3, 4. And each hydrogen can form 1 bond. So I'm going to go ahead and just bond them here. 1 and another hydrogen right here. 2. See, hydrogen each have 1 electron and they only need 1 more. So these are happy and these are happy. Now, carbon can still form 2 more bonds because it still has 2 electrons that are unpaired. And coincidentally, oxygen can also form 2 bonds. So let's draw this here. 1, 2, 3, 4, 5, and 6. See here? This guy right here is alone, and he is also alone. So we can draw a line between them. This one is also alone, and this one is also alone. So we can also join another line. Now, oxygen has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And carbon also has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And each hydrogen has 2 valence. 1, 2, 1, 2. So all of the atoms in this compound are happy now. But let's just double check to make sure that this is right. Basically, I would draw this compound like this, just to make it neater. Okay, so let's check our work. First thing I want to do is I want to calculate the total number of electrons in my elements, and then I want to calculate the total number of electrons in my compound. If they're equal, then I know that this is most likely correct. All right, so first thing, my carbons have 4 electrons. I only have 1 carbon. My oxygen has 6 electrons in total. 6 electrons, and each of my hydrogens has 1 electron, but I have 2 of the hydrogens, so don't forget to include that. So in total, I have 2 electrons. So here, my total number of electrons in my atoms is 6, 7, 8, 9, 10, 11, 12. 12 electrons. Now, let's calculate the total number of electrons as lone pairs and as bonds. So for my lone pairs, I can see that I have 2 lone pairs. So 2 times 2 electrons equals to 4 in total. And then how many bonds do I have? 1, 2, 3, 4. Remember, a double bond still counts as 2 bonds, so you've got to calculate both of them. So 4 in total. 4 times 2 electrons each equals to 8 electrons. So my total number of electrons is 8, 9, 10, 11, 12. 12 electrons. So since my total of electrons before and after are the same, I know that this compound is most likely correct. All right, for that, so now that you're done watching the video, go to Shobi and try some of these on your own. Remember, they're not all going to be very obvious. You're going to make a lot of different combinations and mess up a little bit, but the more practice you get, the easier it gets. So good luck.